We are excited to focus on our road to Google Developer Certification series, targeting the Professional Machine Learning Certification. This initiative is designed to elevate your skills in Google Cloud Technologies and machine learning. This is our gdg.community.dev team. I would like to extend my personal thank you note to all of these who have made it possible to make this happen. They've been extremely helpful in pulling this together. So thank you so much for the time and dedication to bringing this together. This is the team of GDG Seattle. We have been thrilled and excited to collaborate with them throughout this series, bringing the best instructors and experts in this field. This partnership helps us to ensure that you all receive the top-notch guidance and support as you prepare for the certification. GDG Seattle's team expertise and support have been invaluable in making the certification series more meaningful. We have Margaret today with us from GDG Seattle, and I would like to ask her to add anything to this journey and reflect on
it. Sorry, are you asking me to reflect on this journey?
Yeah.
Did I hear that correctly? Yeah, sure. Hello, everyone. Just want to say hello. Today is the last session. It's been really great collaborating with GGG Suri, and who has done a great work organizing this studying series. And I look forward to seeing all of you at Build with AI in person if you are attending. And then hopefully I will see you at Build with AI Seattle and our future generative AI online sessions.
Awesome. Thank you so much, Margaret, for that. Moving on to people who haven't been able to attend our previous sessions in the series. They have all been recorded and are available on the GDG Suri page or even on YouTube. So you can have access to all of these when you have the time on your own to view them. Okay, so let's move on to Vasudev's session here today with MLOps and ML pipelines. Just to give you a brief introduction on Vasudev, he is a Google developer expert in Google Cloud and seasoned professional serving as a staff data engineer at Admiral Group with a wealth of experience in the realms of GCP, Google Cloud Platform, big data, and data architecture. Vasudev has consistently demonstrated his prowess in implementing and industry-leading products recognized by Gartner. Thank you so much, Vasudev, for your extended events and sessions with GDG throughout this series. And we welcome you for the last final session with us.
Thanks, 𝗠liche. Thanks for the introduction. Thanks, everyone, for joining in. Just share my screen. Hope you all see my presentation.
Yes.
Yep, thank you. So today we would briefly discuss about how do we start from framing a ML problem to address it and then deploying it, and how exactly the end-to-end MLOps lifecycle works and what are the different steps in it. So let's say if you're working within an organization, or if you're working on any project, be it your thesis or research project, or if you're only working towards the certification. So this session would help to understand or translate the business problems into the technical problems, and also some tips on selecting the right tooling, because every cloud platform has multiple tools with it, like AutoML, newly AI Studio, GenAI, OpenLMs, and then on the other side we have ML on GKE, data flow real-time ML. So this session would be mostly towards how exactly we would use the right tooling and also translate the business problem into a technical problem. So this would touch upon all the sessions from February, I guess. Some parts of it, because I have taken a couple of them wherein was on purely TensorFlow on Google Cloud, wherein the entire discussion was how do we deploy a model using TFX pipeline or Kubeflow pipelines. So this session would mostly focus on what are the steps that needs to be considered, the right constraints, and what are the ways to overcome it and address the ML lifecycle. So moving ahead, we are on the last session of our journey, I guess, before taking an exam in the next week. We will also discuss through simple questions, mostly on the ML exam. Whatever we see on the ML exam, we will see the similar questions today. So here we are on the session 6. So today's, again, the coverage is on MLOps and ML pipelines. I would also refer you all to one of the good white paper by Google team. It's published way back in 2021, I guess. Some of you might have already seen it and some of you haven't. So it's mostly on the MLOps and how exactly the end-to-end pipeline works. I'll show it to you during the course of this session. So here is the content review. So this some exam tips and how do we register for the exam. There are a couple of slides for that. So moving ahead, so this is the all ML options and the availability in the Google Cloud platform. So how do we go ahead with pre-built APIs or BQML or Vertex AI or AutoML? So let's say if I have a problem to solve and there are 10 different ways to do that. So what is the right way to do that? So in order to select the right way, these are the considerations like data type, training data size, ML encoding expertise, flexibility, and time to train the model. So let's say if I have a data type of tabular, image, text, and video, and you're trying to solve a common use case like object detection, or let's say entity detection or entity recognition as part of a particular NLP or text analytics problem. In such case, you would go with the pre-built API because most of the common use cases are already trained on top of a pre-built API. So pre-built API is nothing but, let's assume it as a vision API or a translate API. So there I just give my text to it and it translates and gives an output. So for that, there is no data required and it's just an API call, like without any ML understanding or ML expertise, I can just consume that API and get the response back. So that is part of the pre-built API. So let's say, when do I choose ML? So BigQuery ML supports tabular data, while the other three support tabular, image, text, and video. So we all know that BigQuery stores the data in a NoSQL in the columnar format, and it would be mostly in a tabular way. So whatever the data which we store in BigQuery, we can apply BQML on top of it. So the thumb rule here is, let's say if I know SQL, I can first consider BigQuery ML in order to build my models. And the spectrum of models which is supported by BigQuery ML is bit limited compared to Vertex AI or AutoML. So I guess there are around 16 to 20 models currently which are supported by BigQuery ML. And here in BigQuery ML, all the data sits right away in BigQuery, and a person who works or wants to build a particular model on BigQuery needs to understand SQL, and the training data size can be from GBs to petabytes, and that should be okay with BigQuery because when we go with BigQuery ML, the advantage is we are not moving the data elsewhere. We are applying the ML model on top of the data where it actually stores in. So that is the main advantage of using BigQuery ML. And the coding expertise is minimum, medium and hyperparameter tuning. So the models can't be customized highly because we are only confined to use 16 to 20 models. I guess when I last used it was around 16. So we can't tune the model as we need other than the acceptable parameters of the BQML existing methods. And time to train model is medium. It's similar to how we submit a query on top of BigQuery. So once we create a model, we can do inference on that particular model. And going ahead with AutoML, so AutoML is again based on the data and train the model. Uh, so let's say if I have the data but doesn't have an ML expertise, then I would choose an AutoML. And it works on a principle of transfer learning implicitly. So there was a time wherein transfer learning was very uh, booming space. I would say before the LLMs and Gen AI. So everyone used to train a base model and apply their own data and do a transfer learning on top of that model. So on those principles, AutoML is actually productionized by different cloud platforms, and in Google Cloud, it's known as I mean, the two service itself is known as AutoML. So AutoML has its own flavors like AutoML tables, AutoML vision, AutoML um, text, and AutoML video intelligence. So now, when do we use it? So let's say if we have the training data but doesn't have an ML expertise within the team, then I would probably choose AutoML over all the others. So that is the reason here we have ML and coding expertise as low, and we can't tune the parameters because we are just supplying the data and put some thresholds, like some metric thresholds on top of the data, and it's done. It would train the model itself. So why I'm actually saying the considerations here whenever I'm explaining this is, so the questions would be similar. So for example, let's say you're working in a big company where the team doesn't know or doesn't has the ML expertise, and now they want to build a model and deploy it. So based upon these sentences or the question, you might need to understand where does the answer falls in, or what is the right choice for the particular situation. And the last is Vertex AI. So Vertex AI is mainly used to build models from scratch. So let's say if your team is highly capable in machine learning and you have lots of data, and uh, you can deal with any type of data. It's not limited because whatever we do are something which we do from scratch, and it needs a team wherein everyone is expertise, let's say in TensorFlow or any other framework, whichever the business is identified as a framework of choice. And then it has its own infrastructure, and it has its, like in the Vertex here we have Vertex notebooks, Vertex datasets. So it's again a big topic in itself, but in this case, let's say if the team has expertise and the data size can be medium to large, and it can be saved in blob storage like GCS, or it can be saved in BigQuery, or it can be directly read from a remote uh, storage area or persistent disks. And the ML and coding expertise is something which is high, and parameter tuning is something which is up to us. If I mean, it gives 100% flexibility to tune because the models which are being built is something um, it's built from scratch. And time to train the model is long because assuming we are building it from scratch and all the AI infrastructure is handled by uh, the users. So it purely depends upon a trade-off between model training time versus the infrastructure we choose. So moving ahead, from this slide, we will be talking about what are the considerations and steps in order to solve any ML problem. And starting from ML problem framing. So let's say if a random business users or business team actually comes to a technical team and ask, let's say, I want to predict whether a particular user uh, will buy a product or not. Let's assume this is a random use case which is given by your business user. So now you want to translate that business problem into a technical problem. So in order to do that, so firstly, I mean, before that, firstly, define a business problem. and then define a non-ML solution, and how the output would be used, and how and what are the sensitivity of producing incorrect results. Let's say if there is an incorrect result, what is the impact of that particular incorrect results, and identifying the data sources. So how exactly these considerations work? So let's say we need to baseline a particular business problem. So let's say if we are solving a vision problem, or let's say the product case, so we need a historical data about all those products and the sales of those product in the different areas and all the user details in order to build a model or to start with. Or let's say if that is not feasible, or if the data is not there, we need outright say the corresponding teams that the data is not available for that particular problem to solve. And the next step is, let's say once we frame the business problem, how exactly it translates to a business decision or a business outcome. And then once the business problem is defined, we need to understand whether it is a supervised or unsupervised machine learning problem, and then uh, think on those directions of solving that. So moving ahead, let's say once we got the you know, business problem, then we would be defining whether which category that does that business problem falls into. So whether it would be classification or regression or clustering. Again, it let's say if it is a classification or regression, then we would think about whether it would be a binary classification or multi-class classification. And let's say if it is a regression problem, then which activation function that needs to be applied, um, whether the label is numeric or continuous. So these are some of the questions which we need to ask ourselves, whoever trying to solve the problem. So I mean, these are very generic considerations again, and there is no hard and fast rule that you need to go through this checklist in order to try to solve the problem. But this is one of the baselining checklist where, let's say, once the problem is in place, so which ML space it would fall into, and in which category the problem would fall fall into, and then we need to identify whether it is, let's say if it is a classification, is it a binary or multi-class classification. And I mean, before that, uh, actually solving a problem, we need to understand all this. And then we have uh, success metrics. So for any ML uh, problem we solve, we might need to understand uh, different success metrics or key metrics to evaluate or validate the ML model before going into production. So few of them is like precision recall, 𝗠liche curve. So these are the standard ones. However, so let's say for balanced data sets, we can directly use accuracy and 𝗠liche curve. But in the ideal world, data would not be normally distributed. So it would always be skewed. And we try to make it normal, but it depends upon the use case. So for slightly imbalanced data sets, we might use precision recall curves, or let's say F1 scores. So these are some metrics which we use. And then let's say uh, we now want to translate these metrics from a numeric format to the business decisions. That should also be helpful. So I'll just take an example. When I started my career way back in 2016 and 17, I was new to the ML space, and I was struggling in translating, let's say if the linear regression model works fine and the metrics was around 60 or 70 or 80, I lagged in translating those values to a business terms. So that was my weakness at that point in time. So I learned from my seniors over the time in order to translate whatever the numbers or the results which we get from the ML models to a business terms. So that is something which uh, everyone needs to understand as the baselining. So for that, like, we need to define the success metrics, key results. So from the technical point of view, let's say I can say that accuracy should be more than 80%. But when I want to translate that 80% into a business terms, so that is something similar to, let's say if I am solving a same retail problem of how many users will buy a product X, I so I should be able to say that 80% out of all the users for a particular month can buy a product X with a probability of X percentage. So these are some of the business terms that needs to be translated as a success metrics and the key results. So moving ahead to the uh, risks identification. So how exactly we can understand the risks and the feasibility. So these are some of the considerations again. So assessing and communicating business impact, ML solution readiness, data readiness, and AI principles and practices. So Google AI principles and practices as a whole available as a white paper again. So that can be accessed. I mean, I'll share the link later. So ML readiness is nothing but whether we have the right data in order to solve the problem, and let's say if we have the data, whether we have the right infrastructure to train the model. So these are some of the questions that needs to be answered whenever we are trying to start implementing the uh, model as a whole. So let's say now as a baseline frame the entire business aspect of the ML model and also translate it into technical, and we have everything in place. Then we come up with the architecture. So now the architecture depends upon multiple use cases. So in the first slide, which we have seen, we have APIs, Vertex AI, AutoML, BigQuery ML. So now the ML solution architecture depends upon where the data is residing and whether we are trying to solve a tabular problem or a audio, text, or video problem. So it purely depends upon data type, structured or unstructured data. So now let's say if these are the considerations, like how do we optimize data use and what are the data connections and automation of data preparation and model training and software development lifecycle best practices. So let's say if the entire data is an unstructured format, it would ideally be in Google Cloud Storage. And if it is a structured data, then it would be BigQuery. And let's say if we are trying to solve an series forecasting problem and uh, we have a low latency requirement, then we go with Bigtable. And so the entire ML process, as mentioned, is an iterative process. So these are the standard steps, as we know. This would be dependent upon different types of problems we are trying to solve, but at a very high level, like data ingestion, validation, engineering, training. So now this choice of solution architecture or the target database is basically the set of requirements of the use case. So let's say if I want to use I mean a user should know like when to use ML APIs or AutoML or BigQuery ML or data labeling service, or when exactly they need to use a custom model on Vertex AI. So this slide talks about that, choosing the right ML solution architecture. And then we have uh, different software components. So we actually want to do a data collection as part of the ML implementation or exploration or feature engineering, logging, automation, monitoring, and survey. So in order to do that, what are the different options we have? So for data collection and data management, let's say if the data is again structured in the tabular format, then we can go with BigQuery. Unstructured is GCS, and let's say we are trying to solve any problem with real-time data, then it would be PubSub or Dataflow. And for all the exploration analysis, ideally it would be like BigQuery SQL connected to a Looker or Data Studio for the exploration analysis. Or we can, if the data size is a bit less, we can use Vertex Bench. It's nothing but Jupyter notebooks managed by Google. And then we can use Python or a data prep. So this is a different service in the Google Cloud uh, analytics or slash AI suite of services, wherein this can be used for a visible ETL and understand the data. And so now let's say we have collected the data and analyzed the data. So now we land in feature engineering. So feature engineering again depends upon understanding what are the right features and which features are correlating to the target. And I mean, there are multiple ways to do that. In order to do that, there are multiple frameworks too. Like let's say if we are using a TensorFlow, then we can go ahead with TF transforms. And let's say if we are using BigQML, then we can go with BigQuery transform. And then we have Keras Lambda layers. So these are these are at a higher abstraction than the TF transform, where that directly can be used. So generally in BigQML, we apply a transform to ensure the transformations are automatically applied during the ML.predict. So it manages, like, I mean, Google BigQML function manages the transform application directly. And now logging and management is something purely depends upon uh, which service we are using. Let's say if we are using native TensorFlow, we can uh, push the logs to a, a target folder and weave the entire graph of the model and each step training loss in the tensor board. So that is also possible. And let's say if we are using BigQuery directly, we can, I mean, BigQuery automatically logs the entire infrastructure logs and user level logs to uh, cloud logging. And from there, we can understand what is the job status and uh, how much time it took to train a model. So these are multiple ways to do that. And then something on the automation. And so there are multiple ways to again serve the model and automation. So now let's say if we have completed experimenting with the model and got one version of the model out. Now let's say if I want to automate the entire training process. So in BigQuery, we have ML.predict and ML.forecast. And then the native service, or I mean, like if we want to go with the cloud native way of it, we have Vertex pipelines where each step of the end-to-end ML training process can be containerized and uh, deployed, can be deployed and automated based upon a certain frequency, so that the new model would be refreshed at a set cadence. And then we have cloud functions for triggered runs and composer scheduled runs. So these are not the cloud native ways of doing it, but um, like let's say whenever the entire ELT or ETL pipeline is built using Cloud Composer, we can still use the Vertex AI custom training job triggers in order to schedule the runs. So these are the possible ways to do that. And then coming to the serving infrastructures. So the default and the cloud native choices go with Vertex AI. And here we have two ways of predictions, again, batch and online and endpoint prediction. And then we have cloud run. So here again, let's say if our entire code is in the format of a container and we want to manage our own infrastructure instances, then we can actually publish our model on cloud run. And then we have BigQuery, wherein it only works as a batch predictions for all the BigQ model using ML.predict function. Then moving ahead, let's say if we want to build the secure ML systems and privacy implications. So these are um, the important aspects whenever we are trying to build a model in an organizational level. So, and what are the considerations we need to make in order to uh, you know build a secure ML systems. So data loss prevention API is a key API. Uh, it actually uses the concept of uh, data anonymization, data redaction. So the primary aim to use that is, let's say if I work in the UK market, and we have the GDPR regulations and PII regulations in place. So whenever we get some data, we run that data through a DLP to check whether there is any sensitive data like uh, email address or mobile number or any other details about medical conditions of a particular user of our company. So these are some of the things which are considered or classified as a sensitive or PII data. So now let's say if I want to train a ML model on top of it, I cannot use the medical condition of a particular user as a feature in order to train my model. So let's say if I use it, what happens? So we operate in a regulated environment, and there would be huge fines or certain data leak breaches. There might be a number of cases, but the idea is not to do that. So how do we avoid that? Using techniques like data anonymization, or using off the shelf of APIs like DLP API to scan my entire database. Or let's say whenever I'm loading the data into Target, BigQuery, or GCS, I would do a scan of my entire data using DLP. And there is a lot of due diligence and the governance process comes in an organizational level. Like we have some data governance tools which actually does this over the time, like every week or every 10 days or every month. That's a different part, but there is some ways to handle it at an organization level. So how do we handle the sensitive data like masking and hashing, and then throw it away? So we would throw it away. Like throw it away is nothing but we do not consider the data, like whenever that data doesn't make any sense. But yeah, uh, generally we don't do that. But yeah, and then we conceptually bucketize the data to make it not identifiable. So this is something which most companies do, and this can be achieved in multiple ways by building their own data anonymization framework. So one such framework is built by JP Morgan to anonymize their own internal data. And there is a research paper on that as well. So if you're interested, please DM me, I'll share you that once I search it. And then we have data preparation. So let's say now the business problem is defined and it's translated to technical problem, and we have chosen all the right tooling and frameworks and deployment strategy and inference strategy for the entire ML problem. So now we are trying to bring in or at a stage where we want to do an ML implementation. So for that, as a first step, the data preparation and processing. So we have multiple ways to do that again. So one such consideration is ingestion of various file types. How do we handle different file types, whether we have structured on unstructured data, videos, audios, text files? How do we handle that? And database migration and streaming data. So this purely depends upon the use cases. But let's say if we have analytics workloads and all our data is not transactional but rolled up or uh, tuned data. When I say tuned data, we are only choosing few data points from the entire transactional data and make it analytical. Then we choose Dataproc. And let's say we are doing a database migration of Hadoop or Spark or any similar tooling, then we use Dataproc. And let's say if we have streaming data, the data ingestion is with PubSub and processing with Dataflow. This is a standard, but this is not the only way to do that. Let's say if there is a streaming data, I can uh, get the data from PubSub and store it in BigQuery and then use it. Let's say if I want to do real-time model training and real-time model pins right away, then I might use ingestion with PubSub and process with Dataflow. This is what the best practice of Google suggests to go ahead with. Then we have data exploration. So there are multiple I mean, as I said, in order to solve a problem, there are multiple ways, but for EDA as well, there are multiple ways to do that. Like, let's say if I have 10 GB of data, I can sample that out and build my own charts and understand whether the data is skewed in the random sample which I have taken. Let's say if it is skewed, I can apply the same on the entire 10 GB of data. And most of the times where I have experienced few errors is I use my own laptop to try to connect to BigQuery and read the entire data. But I mean, when I was learning as a beginner, I used to do that. But I would suggest if you are in the learning stage, don't do that. You can turn up your Vertex AI Workbench notebook directly and connect with BigQuery and run the queries on top of it directly. Because way back in 2015 and 16, we don't have a feasibility or flexibility of doing that everything on cloud compared to what we have now. And EDA is nothing but understanding our features and data points, like doing some hypothesis tests and understand the correlation between the features. So that can be achieved in the Vertex Workbench notebooks, and like BigQuery, writing the BigQuery queries, like using pandas, Matplotlib and Seaborn in Python. So these are few metrics, like let's say if this purely based upon which problem I am trying to solve, like time series forecasting or a classification or a regression problem. And then we move ahead to data pipelines and the considerations. So batch and streaming data pipelines, data privacy, monitoring of the pipelines, handling missing data, handling outliers and transformations, and large, how do we manage large samples? So again, the top two options which we have is Vertex pipelines with Kubeflow pipelines. So that is a cloud native approach again. So just to talk about some of the history of Vertex pipelines. So natively back in 2017 and 18, Google came up with Kubeflow pipeline. Kubeflow is again an open source framework, and Google tried to productionize it as a service with Kubeflow pipelines back in 2018 and 19. And thereafter, they have brought this something called AI pipelines. And I mean, at that point, there was no Vertex AI. So it was known as AI platform. And at that point in time, it was AI platforms pipelines. And now, once the Vertex AI has come into the market, they have named it as Vertex pipelines, where uh, previously we used to manage the entire Kubeflow infrastructure, but now it's purely serverless, wherein I try to run and submit my pipeline and it executes on its own infrastructure. So that is the reason Google suggests to use the Vertex pipelines as a base. Let's say if our use case doesn't fits in with the Vertex pipelines, then you search for a different option of Kubeflow, or let's say if I'm using TF transforms in order to solve my problem, then TFX pipelines would be a right option. And how do we handle missing data? Again, it's I can impute the missing data, or if it is not important, then just ignore. Or let's say if there is a lot of missing data, then create a separate bucket and uh, add the categorical features of missing data. And then how do we handle outliers? Again, there are multiple ways. Uh, and we can keep our threshold limit of the values in between, like min and max. Or I mean, there are multiple ways to do that, but here this is the only example which we got. So moving ahead, how do we do a feature engineering and considerations? So data leakage and augmentation, feature selection, class imbalance handling, and feature crosses and encoding structured data types. So whenever we are trying to deal with data, we need to first understand what is the encoding of the data, whether it is UTF-8 or 16, or which variant of data encoding it is, like LE or LF or LS. This is important to firstly handle the data types and values. So the reason being, uh, BigQuery may not support certain types of data in large amounts of size. We need to convert them first and then load the data. And the next step is, let's say if we are handling a very critical data of highest precision of like 0.0006. Now, if we change the encoding of the data, these values might not be considered and directly considered as 0.00. So this would reduce the write precision. And so a feature process, like feature process is also important. Like it's a synthetic feature that encodes the non-linearity in the feature space. So by multiplying two or more features together. So it's similar to a cross product. So let's say if we want to create a new feature, I can select two features and multiply it and create a new feature. So this is, I mean, this is useful whenever, let's say we uh, have a two different features and two different features denoting a single target problem, then we tend to use this feature crosses. And then we have feature selection. So this purely depends upon the correlation. And I mean, for this depends upon the sets of problem which we are trying to solve. Again, ANOVA is for forecasting and correlation and regularization. So I'm not going into the core aspects of how this is done as part of the correlation and what needs to be done and the action to be taken in the interest of time. But let's say now the data preparation is done. Now let's understand how the model development happens. So how do we choose the right model? It purely depends upon uh, the use case which we are trying to solve and the engineer or the research scientist who is working on the problem. So we have multiple uh, model architectures like decision trees or booster trees, transformers, CNNs, LSTMs. Again, this is an entire field in itself where which problem is appropriate and which model is appropriate to the target problem we are trying to solve. So the consideration is choosing a right ML architecture, model architecture is important. And the second part is we need to be aware what are the different uh, frameworks which are available out there in the open source or wherever we are trying to get the information from. So one such thing is like transfer learning. So we need to check whether the transfer learning can be applied in this problem space or not. And then we have regularization and overfitting. So whenever we are trying to develop a model, we try to avoid overfitting because I mean model outperforms from the state where we expect it to. So that is the reason we tend not to decrease the overfitting. And then let's say now the model has been developed, then we try to train or train and test the model. So the first consideration is productionizing. So in order to productionize, what exactly we need to do? So that is the key aspect. And training a model as a job is different in different environments. Again, way back in 1980s or 1990s, where uh, let's say if we have a different environments of Windows and Linux. I mean, this problem is still today, but a bit less once we have seen Docker and other coming into the um, I mean the core software architecture software problem. Let's say if I write my code in Python 3.7 or 2. Like 2.7 is not deprecated, however, but if I write my code in 2.7, that might not work in 3.10. So this problem would also happen in ML as well. So how do we track or trace that and solve that whenever we try to deploy the model in a different environments and try to train it? And tracking metrics, retraining, redeployment, and model explainability and model performance. So these are some of the important aspects whenever we are trying to productionize the model. And so the best practices, again, Google suggests to use the serverless distributed training products like 𝗤𝗂𝘂𝗃𝗄. So we have something called 𝗤𝗂𝘂𝗃𝗄 custom training, wherein we can build our model, containerize it, and submit it to the custom training. And we can um, fit in our couple of features. Like when I say features, like couple of aspects, like choose the amount of time the model that needs to be trained and the maximum cost um, that you can afford to train the model. So I have seen this couple of months back. So now you can choose those things and the model trains itself. And then we have model checkpointing and early stopping. So in Vertex AI, we have this. So we can define a manifest file, and in that we can write what is the early stopping criteria, and that would actually uh, used, like let's say whenever my model reads the overall um, global minimum of my loss, then please stop the model training and do a checkpoint. So these things can also be handled in Vertex AI. And so baseline of comparing the baseline models, and model explainability is something which is important as well, like using SHAP or techniques of implicitly provided by Vertex AI or gradients. Again, in order to do that, SHAP is a good library. So if you aren't aware of it, please read through what exactly a SHAP is. And then for the training and serving, we have few considerations as well. Distributed training and scaling prediction. So distributed training is again can be used in any cloud platform, but in Google Cloud we have GPUs and TPUs availability, like both Tesla and NVIDIA Tesla and H100 GPUs are available. So the infrastructure on which you train on purely depends upon the problem you solve. Let's say if you're trying to solve a vision problem or uh, a audio problem, in such case GPUs might be useful. And how exactly you can choose your strategy, like distributed strategies, uh, you can define that as part of your configuration code of TensorFlow. Like it's just 10 lines of code wherein you can, let's say if you're training on your laptop, it would be a single core training, and let's say if it is on the Vertex AI, it would be distributed, and you can choose the right set of like T4 TPUs or H100 GPUs based upon your need. And then for predictions, so prediction depends upon multiple cases. Like I'm trying to solve a real-time prediction or a batch prediction or an online prediction. So for all those cases in Vertex AI, we have prediction endpoints wherein the underlying infrastructure is a virtual machine where our entire model would be deployed and can be exposed as a REST API to the other product teams, wherein they can consume the ML model by sending a payload and it would get a response. And the other other ways to do it is using Cloud Run and BigQuery batch predictions using ML.predict. And how do we automate the pipelines is something which is also important. So let's say now our ML model is trained and deployed for the first run, and now we want to do an orchestration of the entire pipelines. So for that, we have Vertex pipelines like Kubeflow and TFX are the two different frameworks which are available. And then let's say if I want to if I'm already using in an organization setup like as a ETL tool or the orchestrator as Cloud Composer, I can use the Airflow DAGs to um, trigger the DAG runs. Like whenever, let's say if once my data is landed in BigQuery, I want to train a new version of my model. How do I do that? In the last task of the Cloud Composer, I'll trigger a custom training job of Vertex AI where it would read the data from BigQuery and train the model. So this is something which can be done as part of the Cloud Composer. And Cloud Build and constructing a pipeline with Kubeflow SDK. And I mean, these are some ways, but last two are the ways to achieve it, but not the best way to solve a problem. And then we have serving the considerations whenever we are serving a pipeline. Like we have online batch and caching, and Google Cloud serving options, like native cloud native options, and testing for target performance, and trigger and pipeline schedules. So in this case, like we have different types of serializing models. Like this purely depends upon the framework which we are using. Like, let's say if we want to develop a model to deploy it on the edge, then we have a TF Lite. And if we are building a scikit-learn pipeline, then it would be of a different format. Right. So this depends upon, I mean, the model serialization depends upon the framework we use, and the serving option is depends upon um, the cloud native approach of using Vertex AI prediction endpoints, or like App Engine. I mean, this is not the Google best practice suggested way, but I mean, because App Engine has a limitation on the uh, I mean, on the RAM size. I mean, I remember it as 32 GB, but it might be changed in recent times. But we cannot increase the inference RAM size more than 32 GB. Then in that case, we may not use it mostly. For all the lightweight models, we can consider it, but it purely depends upon the customers and the use cases. And cloud is the unmanaged way wherein we need to manage the containers and the infrastructure and the latency as well. And BigQuery is for all the batch predictions from the SQL point of view. And how do we handle the metadata at an organization level? So we have something called like model lineage and dataset lineage as well. So in the Vertex AI, like whenever we deploy a model as part of the Vertex pipelines, like sorry, whenever we automate the entire end-to-end ML model, we I mean we can see the artifacts, like what are the data sets we have and what are the intermediate metrics it generates. So the entire end-to-end model um, development pipeline can be viewed and tracked. So it provides an implicit lineage of the model and dataset. And then we have model versioning with Vertex AI. So we have something called Model Garden um, and Model Repository. I remember the names correctly, I guess. So wherein we can save save the models just like we save our code versions and releases. So the model repository is mainly used. Let's say if we want to uh, push the model across multiple environments like dev, QA, and pre-prod and prod. So that is the right way to push the models into the upstream or downstream environments. And then we have ML model optimization and maintenance. So this is for the performance. I mean, in the long term perspective, how the model should work, like what are the strategies for the permissions and common training and serving errors. Once the model is deployed, how do we track the model performance, whether there would be any drift in the performance or not. So continuous model evaluation is an important factor wherein um, that is defined by concept drift and model drift. So this concept drift and model drift may cause models to become stale over the time. So let's say if the model is trained on a different distributed data, now um, the incoming data for the prediction or inference may be a differently skewed data. In such case, uh, if we compare the predictions data with the ground truth, then we can understand what is the drift of the model once the model has been deployed in the production. So model deployment is a continuous process, and it may be necessary to retain a model with fresh data to improve the predictions. And continuous data model evaluation is the only way to retrain the model. So let's say if the model prediction accuracy falls less than 50%, I want to retrain the model again and check my metrics and validate whether the newly trained model is performing the right way or not, and then deploy it again. So these are some of the strategies we take whenever we want to do a continuous model evaluation and monitoring. And the other part is tune performances of ML solutions. Again, whenever we tend to train the model, there might be a large data sets, and uh, in some cases we might need to consider uh, the value which the model is getting to the business. Again, going to the day one of translating the business problem to a technical, and the results of model into a business value proposition. So this is something which also needs to consider on optimization and simplification techniques. So at this point, we have seen the step one of framing the ML problem, and step two of ML solution architecture and data preparation, model training, and deploying the model and continuous monitoring. So I'm now open for any quick questions. If there are none, we can go with some sample questions. I forgot to ask, do I have some more time, or I'm running out of time?
No, we do have time, Vasudev, and the questions are in Slido. We were thinking to take them towards the end, but
Okay, if that is the case, then I can proceed.
yeah.
Thanks. So come back to the exam information. So it's again online or in person. Again, this depends upon which part of the world we are in. Uh, I guess. Yep. And the exam length is of 2 hours, 50 multiple choice of multiple select questions, and you can register at this link available on the slides. And these are some tips and tricks. So we will now go with sample questions. So you can take some time to read this question, and we can proceed in next 60 seconds. I'm sorry, I couldn't see the chat, but you can put your answer in the chat.
I'll read the answers for you.
Thank you.
Okay. No input yet. Please reply in chat if you have any answers from the options. We get B, option B.
Okay.
Yeah, B so far.
Okay. So we'll try to understand the question first. So I mean, you can apply this in your own examination, but I mean, I personally follow this. So I try to break down the question into multiple parts. So the target here is to build a object detection model for a small startup company, which is used to identify whether what is the company's logo, um, where the company's logo appears in the image. And we have been given a large repository of images, some with logos and some without. So these images are not yet labeled. So this is a key aspect. So now we need to label the images and then train and deploy a model. And what should we do? So firstly, we understood that the images are not yet labeled, right? So now there is a huge task. So we have a large repository of images, and we are working for a small startup company. So we need to understand there are very less people or very less headcount of employees available out there, and all the images that needs to be built. I mean, whenever we are trying to train the model on those images are not yet labeled, and there are a lot of images. So that means if we tie this up, we can understand that we might need a I mean, we might first need to do a data labeling, right? So that is the first consideration. So now after that, we can try to understand what each option is. So use Google Cloud Data Labeling Service to label your data and use AutoML object detection to train the model, train and deploy the model. So that is the first option. So here I can understand, like, this is the option which is giving me a data labeling service, and it's suggesting to use AutoML object detection. So how do I decide which particular way I need to go through? Let's say after seeing a question, so now I want to know whether I need to go with Vertex AI or BigQuery ML or AutoML or APIs. I mean, when I say APIs, ML APIs, like Vision API in this case. So here so we would we would do a elimination of all the possible 4 ways of doing it. So currently we can understand that we are handling images, correct? Logos and images. We can eliminate BigQuery ML. So ideally it only goes with tabular data. So now we have 3 more options. So let's say if we consider Vision API, do we have an option of having that? So here we have, in the question it says you need to build an object detection model. So when we try to use ML APIs, in this case Vision API, they are implicitly pre-trained APIs right off the shelf, wherein I directly give the input, it gives me a response. We may not train the model using Vision APIs. So now we only have Vertex AI and AutoML APIs. So here we have an option with Vision API. Use Vision API to detect and identify logos and pictures and use it as a label. Use AI platform to build and train a convolution neural network. Right. And then we have other options to create 2 folders, one where the logo appears and the other where it doesn't. Manually place images in each folder and use AI platform to build and train a neural network. So other option is also more or less same. So let's say if we go with option C and D, so each option suggests to do a labeling task manually. So now again, the key aspect of this question is a small team, data is not labeled, and there is a large set of images. So tying all these 3 up, I would suggest to go ahead with option A. The reason being, uh, as a small team, I need to get this entire process done as soon as possible. And we have a Google Cloud service called data labeling service, where how exactly it works is, uh, let's say I once create a ML data set in Vertex AI, and then I can subscribe to a Google Cloud data labeling service, which labels my data. And let's say I'm again in small team, I don't have, I mean, I'm considering or assuming myself that as a small team, I might not have a ML expertise uh, in that team. So again, when I have data, but I don't have expertise, I would ideally choose AutoML over Vertex AI, the 2 options which we have left over with. So I can use AutoML object detection to train and deploy the model. So I guess A is correct, but yeah. So these are, I mean, this is my thought process. I'm trying to solve these questions, and I would like, I hope the exam is somewhere in the next week. So I would suggest to uh, drill down this each question into these ways. I mean, there are few questions which are pretty easy right out of the box, wherein you want to use a serverless service. Then you would eliminate all the options of using GKE, for example, like using GKE right away. And then you can eliminate, like, let's say 1 or 2 options and target. I mean, I'm purely speaking from the exam perspective because I'm talking about exam questions. But from your experience, you can right away do that as well. But again, the bottom line is to uh, make us well versed with Google Cloud Platform as a whole, but not only the examination point of view. But so again, we are dealing with the exam questions, so that is the reason. I'm speaking in these terms. Yep. So this is about a textile manufacturer, and we have been asked to build a model to detect and classify fabric defects. So we have already trained a machine learning model with high recall based on high resolution images taken at the end of the production line. So now we want a quality control inspectors to gain trust in the model. So which technique should you use to understand the rationale of your classifier? So any quick answers, 30 seconds.
Any answers for this one? Monica said C.
Okay.
Yeah, we are getting option C. Yeah, I think, yeah, we are mostly seeing C.
Okay. Yeah. So we would just break this question down. So model to detect and classify fabric defects. So from this, we can understand that we are dealing with an image related ML model. And it says we have already trained the ML model. And this is a key factor wherein we have the high recall based on the high resolution images which we trained on. And then now we want to have a quality control to gain the trust of the model. So here, nothing but we want to build a metric, or we want to build a validation for our model whether the results are uh, correct or not. So that is the end goal, is what I understand from the question. So firstly, we need to understand what are the correct ways to do that. So let's say if we have in this scenario, and I have built a image classifier, and in order to understand or validate my classifier on based on the images, I can perform different. I mean, it's speaking about the, again, I guess, high recall, right? So I can perform k-means clustering, or I can perform like PCA as well. So just understand the rationale behind it. So let's say if we go with PCA, so ideally PCA is used for dimensionality reduction for higher dimensional data sets. So in this scenario, it might not like offer any added benefit. And let's say if we are using k-fold cross validation. So now cross validation is used mainly to understand how exactly uh, the training and testing data, like, let's say if we have a testing and training data, how exactly each output matches itself with the testing and the validation. So that's something which k-fold cross validation gives us. And let's say the option B. So use the integrated gradients method to efficiently compute feature attributions for each predicted image. So whenever we are dealing with the gradients, or let's assume the k-means clustering. So in the k-means clustering case, I mean D, I'm hoping B or D, but let's analyze both the options. So use k-means clustering to group similar images together and calculate DB index to evaluate separation between clusters. So let's try to eliminate D or B. So whenever we are trying to apply k-means clustering, so we are trying to group the entire images and understand the pattern itself. But in the question, we understand that we want to detect or predict the quality of each output of the classifier. So for that, D might not be used here, but D is the right option to analyze the overall performance of the classifier. But if we are doing it image by image, D might not be useful. So let's say if we go with B, I guess B is the, okay, I don't have the right option slide, is it? Okay, so I guess B is the right option. That's my wild guess, but yeah. So it identifies the pixel of the input image and compares it with the prediction image. So that's what the integrated gradients do here. I guess I lost a couple of slides in between, but yeah, we'll proceed in the interest of time. Now, so I'll just give 30 seconds again in the interest of time. Yeah.
Any option choices?
This should be pretty straightforward or easier for to others, but yeah.
Okay, we got one answer, D.
Yeah, it's the right answer.
Well,
Yeah. So just to break down, so we have the model V3CNN, which is pre-trained. So here we have around 10,000 images. So once we read this question, we need to understand these aspects like TensorFlow, distribution strategy, and training job. And the key aspect in this question is wall clock time. How like, so what TensorFlow distribution strategy and AI platform training job configuration should you use to train the model and optimize for wall clock time? So the end goal here is to optimize the wall clock time and the distribution strategy. I mean, let's say if there are a couple of options of mirror strategy, it might be a bit difficult to answer, but in this case, the default strategy would be of single node, like single master node, and for this might not work. And one device strategy is something which wherein it would, so the end goal is to reduce the wall clock time, right? So we would choose the best possible distributed strategy of like going ahead with option D. So in this strategy, we can perform distributed training. Like there is only a single copy of variables because we are using a mirrored strategy in itself. So this might not be the case for option B and C because one device strategy does not distribute the training across multiple devices. So this is a pretty straightforward one, but yeah. In the interest of time, I'll these few of these. I mean, I guess these slides are available with you. You can refer that later. So next steps, we have sample questions like which we discussed. And there are a set of sample questions which are also available on the like on the certification website. Sorry, I remember it. Google Cloud certification website. There are some sample questions, and then these are some of the code labs or quick labs, I guess. Yeah. So I guess that's it with this session. Any questions?
We have a few questions for Vasudev on Slido.
Yeah.
Do you want to share the screen, Yashi, for the Slido, and we can, Vasudev can read them?
Yeah. Okay, awesome. There are questions that are logistics that we can handle, but the ones that Vasudev needs to answer, we can just go through them first. So the first question is, any other sample workloads learn tune GKE clusters for AI training? We have shared the Kubernetes engine batch ML workload.
So is this about how do we tune the right sizing of clusters for AI training? Let's say if that is the question. Uh, so firstly, whenever we want to turn up the GKE or identify the number of pods or nodes in order to uh, train the ML model for AI training, so we would consider some of the frameworks first for distributed training. And so there are multiple layers of abstraction. So the first level of abstraction is the infrastructure itself, and the second layer of abstraction is the framework like TFX or um, JAX or other frameworks for distributed training. And then on top of that, we have our ML training code, and then on top of that, we would be having the data. So now, in order to choose the right infrastructure, so I mean, at least my experience is limited in this space, but I use a trial and error way to check whether, let's say, 3 nodes are failing, and then I use a high M CPU instances, and then I try to use it for AI training and understand the metrics of. I mean, in the logs, I will understand the usage of CPU and memory usage, and then I try to increase or decrease that. So that is how I would do that in that situation. And if you want any other references, please DM me. I can share that.
Awesome. Yeah, we can take these voucher questions ourselves later. What else do we have here? How do you decide if a business issue should be solved using machine learning? What considerations are needed?
Okay, so I mean, this is a day one question. So, I mean, this is a good question again, because nowadays, due to the buzzwords here and there, I mean, not only developers like me, but also the business leaders overlook the possibility of solving the uh, any business problem right away rather than focusing more on using Gen AI or anything for that matter. Because I mean, I have seen this happening, so that is the reason I'm stressing on it. But this is not the case all the times. But in order to answer this question, so firstly, you need to evaluate whether you can solve that. I mean, solve that business problem right away using any decision or rule-based engines. So let's say if you're trying to solve a business problem, and that can be handled with a set of rules. So one such rule engine is called rules rule engine, which is available open source, where you can define the rules and whatever the data which is incoming would run through that and then gives us the output. That is good. And then you have something called decision management system. Um, so that is known as DMS, wherein that can be used in the case of ML. And then let's say if that is not possible at all, then you would slowly come into ML. So when we say ML, it would not directly be linear regression. It would be starting from the lowest level of abstraction, whether the core statistics can solve your problem, like building a hypothesis and do a z-test or t-test, whether that solves your problem. So let's say if that doesn't, then you come to linear regression. I mean, when I say regression, you can also classify your problem first and then trying, I mean, try to deep dive into each, uh, like each case, like binary classification or linear, and then moving one step ahead for each try. I mean, over the time, you will understand which one to choose, but this is the way which I have learned myself.
Awesome. Okay, so I think you mentioned about the JP Morgan data paper. Could we get the link to that? That's one of the questions here.
Um, I need to search for it. I have in my OneNote, but yeah, I'll share it separately. Sorry for that.
Sounds good. Yeah, perfect. Okay, Next question. During the data prep and processing, where in the pipeline is synthetic data being added if required? Also, what about the application of feature crossing?
So the synthetic data is added once we analyze the data, like doing a EDA, and there are multiple. Sorry for interrupting. I'm sharing the link for the JP Morgan I just searched. Yeah. So yeah. In order to answer that question, there are two ways, which at least from my experience I can recall is. So let's say if the data whichever I'm handling is sensitive, and I can't use the data as is, I can generate the synthetic data which is similar, which have the referential integrity, and then I can replicate that synthetic data. So I used a package called 𝗏𝗃𝗃, which again open source, to generate the synthetic data and use it. And let's say the other case is we have a lot of missing data, and I want to build, I want to impute the missing data, then I would use synthetic data. So those are the two cases where I use synthetic data. Did that answer that question?
I think they also mentioned something about feature crossing. Let me see where that goes.
Yeah. So feature crossing, yeah, example. Yeah, I got it. So feature crossing is mainly used, let's say, let's consider a supply chain example. And in the supply chain example, let's consider two products. And let's say if we consider two products called shampoo, in that shampoos, we have two types, like type 1 and type 2. And we understand type 1 sales is more and type 2 sales is less. And uh, the profit ratio of type 1 is more, but the type 2 is less. But those two, type 1 and type 2 shampoos, rolls up to a single category of shampoo. So let's say if I want to make it more clear, let's take an example of Coke. And we have normal Coke, Coke Zero, zero sugar or something like that. Now let's say if the zero sugar Coke sale, like profit is more and the sales is more, and normal Coke, the profit is less and sales is less compared to the zero sugar ones. Now I want to roll it up and weave the feature at a master or at a Coke level. Now let's say I have sales, profit and loss columns. Now I want to combine these columns to get a single view of the entire Coke sales. In that case, I'll apply a feature cross. I mean, this is not the only case, but on top of mind I could recall this wherein we can apply the feature cross.
Awesome, thank you. We have one more question here. Oh, okay, so that's just a comment. Thank you so much. They appreciate your reasoning process for deciphering the questions and options. It's quite impressive.
Thanks for that.
There's one more question. Can you please elaborate further on the lineage for models/data sets and how that differs from basic versioning?
Okay, so lineage is different from versioning. So lineage is a topic of discussion when we train the model from step 1 to step n. So now let's say in the step 1, assuming I have the data, 100% data. In step 2, I have test data, train data. In step 3, just a hypothetical case, I have few metrics and test data, validation data. And in step 4, I have training metrics and test metrics, just a hypothetical case. So let's say now I am in the step 4 and I want to track down all the upstream data. So let's say if I have a validation data, I want to track all the upstream. What is the source of my validation data and where it is coming from? So let's say if I have a capability to track from step 4 to step 1 and trace down my source data of 100% data set. If I have this capability of tracking both the ways, downstream and upstream, then that is known as lineage in this context. So this lineage works for a single training of ML, a single training of an ML job. And when we speak about versioning, each version has its own lineage. So when we say model lineage, so what is the history of that model? Which training version, which data version the model has been trained on? So that is a key difference between the lineage and the versioning of the models.
Awesome, thank you. I know we are right on time. Just want to take this last question. Have you implemented federated or privacy-oriented learning on mobile devices? If yes, what is your approach for edge-based ML training and inference as an MLE?
Okay, so I have implemented federated training, but not privacy-oriented learning. And so mainly I haven't trained the model on mobile devices or any other edge device, but I have deployed and did an inference on mobile and an edge device like NVIDIA, just Nano. So when we speak about, let's say, only Android, I haven't got experience with iOS, unfortunately. But let's say if you want to deploy it on a mobile device, so the first step is to train the model using the target format like TF Lite, and the next step is to quantize and distill the model. So the quantization applies at different levels by not missing the model performance. So let's say with the quantization, the overall model size would be decreased by 20 or 30%, let's assume. So that model can be directly deployed onto a mobile device. So in Android, we have ML Toolkit, wherein that can be used, but I'm not a core Android developer, but these are some things which we can do. If you have still some questions, you can reach out to me on LinkedIn. Probably I can help you out.
Thank you so much, Vasudev. I know we are 2 minutes over our time. Thank you so much for going over all these questions. And any of the questions that have not been answered and are expertise related, we'll have them answered on our Discord from mentors, or if you have any specific questions, Vasudev is open to receive your questions on LinkedIn as well and connect with you. Yeah, Preeti, do you have anything to add?
Yeah, thank you, Vasudev, for such a lovely session, and thanks for being here for almost every session. You delivered 3 sessions with us. It's been great. For those who missed, session from Vasudev and Margaret and other instructors that we had, please go to our landing page, navigate to the past events, and you'll find the sessions with recordings and with slides. This one particularly would be uploaded next week, most likely by Wednesday. Now, I'll come back to the questions regarding the exam voucher. So the scenario is that GDG Surrey and GDG Seattle, the volunteer team, we organize these sessions to help you prepare for the exam. And voucher was not really part of it. But when we received the request from some of you, then we tried to go back to the team and we tried to request them to help us with the vouchers. And it took some time. We secured some of the vouchers, and for that, the simple requirement was to know your willingness to take the exam, and that would have happened for us. That would have been just that sheet, right? That you want to take the exam, and this is your profile, and we allot you the vouchers based on your courses as well, the courses that you complete, right? Now, whoever, most of us I see added their credentials today. For that, I cannot guarantee the vouchers. None of us can, because we are also the volunteers just trying to bring together the content to you. But all I can assure that I'm going to go back, and the other team members, we all are going to go back and request for additional vouchers. If we secure them, you will get an email from us. And for those who have already been added to the pool, because we did mention about the vouchers after session 3, so we already have a couple of people lined up for that. They will also get it in the email. So yes, we cannot guarantee vouchers to everybody, but we can just guarantee this amazing content that was by Vasudev, that was by Margaret, Sam. There were other instructors that we had. Regarding how much time do you need to complete, just in case there are vouchers we secure, how much time do you need to complete all these courses? Again, we can be your advocates. We can just take your profiles and present them to the team, and we can say that, okay, you there is no other way to show your dedication towards the exam. So we could just show your profiles, and we could just say that, okay, you see people are on the track, and we would like to secure more vouchers. So I would just say try your best to complete them as on your pace, and yeah, that's all. Regarding the credit, some of us said that credits are going to expire in April. If you have been consistently RSVPing to more than one of our events, then Google backend team is already taking care of you, taking care of the credits, like to add you into the credits timely. So sometimes they add you to the pool from April to February to April, and then there would be some added March to May. And as one of someone said that it was like 60 days window. So they did tell us that it would be the 90-day window. But if you face any issues there, just let us know in the chat, Discord chat. We can go back and we can try to sort that out. I hope, 𝗠liche, I answered the questions around the voucher.
There's one more question. How long is the voucher going to be valid for?
Yeah, that you'll be notified in the email that if you receive for the voucher, you'll get notified there.
Again, I think we've covered everything, but if there's anything remaining, we get them on the Discord, and we'll update all the attendees as well. Thank you so much, everybody. Thank you, Vasudev and Margaret, for being here today. We loved having you both. Thank you, everybody, for your attendance, and I'm sure that we'll get to all of these questions in our Discord channel. Thank you, everybody.
Yeah. Before we let everybody go, I'll just go on over one slide. If you could,
yeah,
share. Yeah. So for the exam, tips and how do you register for the exam? We have added the link into the that one document that we shared. I'll share it again, just in case. It's the complete PowerPoint. You can go through, the entire PowerPoint, and you can see. It will just help you register, and get started with the exam. And if you happen to register, yeah, this is the last session, and if you happen to register for the exam, just keep us posted. If you want to support us, just tag us and tag the instructors on LinkedIn. That would be great. And let me quickly share my screen. 𝗠liche, I want to go over the instructors we had so far. Sorry, we are going over time a little. So I would really like to thank all the instructors that we had in this series. Some of them were local from British Columbia. Some of them were from other places around the world. Margaret joining us from Seattle. We had Raghavendra joining us from Okay, I forgot the place.
Singapore.
Singapore, yeah. And Vasudev, it's already around night at his place. He's joining, from totally different place now. So yes, I would say that we tried to bring together this thing for you to benefit with the content, and our instructors were generous enough to dedicate their time. You can go to, again, to the past events. You can find the sessions there, the slides there, and the YouTube videos there too. Please follow them on LinkedIn if you like their content, and if you have any questions for them. Thank you. I think we should maybe stop recording. Hey, Margaret.
Hello.
I would ask Margaret and Vasudev, both of you, how has it been for you? And I'll stop recording, just
For me,